This is 2.4a notes, multiplying binomials and GCF. So we're getting into factoring. So we're going to start with just multiplying, simple multiplication, pretty easy to deal with. And then we're going to look at the different types of factoring and do some simple factoring problems. Okay. So when multiplying, or I guess your essential question, how do you multiply binomials? When multiplying two binomials, oops, that's a typo, that should be TWO, binomials like x plus 2, x plus 3. Remember, FOIL, first terms, outer terms, inner terms, and last terms, or distributive property, or box method. 3 different ways to get to the exact same thing. If you learn FOIL, that's fine, but I'll tell you, these two are going to be the only ones that you could use the entire year. FOIL only works when you have 2 terms times 2 terms, and we won't always have that. Okay, so be careful. I would recommend distributive property. That's what I'm going to use. It's the actual property that you're using the whole time. Some people like the box method. You can ask about those things if you like. I'm going to do everything distributive property. Okay. So, example 1. Usually when you multiply two binomials, you will get a trinomial that looks like ax squared plus bx plus c, where a, b, and c are whole numbers or some sort of numbers. Okay, so multiplying, you start with the first term, so I'm going to distribute this whole thing into this whole thing. So x times x is x squared, x times negative 3, negative 3x, make sure you're careful about the signs, 8 times x, and 8 times negative 3. And all we do is combine like terms. So remember, like terms are the same variable with the same power. So there's nothing else with an x squared. There are 2 things with an x, and there's nothing else with just a number on its own. So we get x squared plus 5x minus 24. You just combine the front parts. Do not get rid of or change the variable. Okay, so negative 3 plus 8 is positive 5. Done. Multiplied out. Okay, then we did this on the next one. So 3x times x is 3x squared. 3x times negative 5 is negative 15x. 2 times x is positive 2x. 2 times negative 5 is negative 10. Combine our like terms once again. Only the x's have like terms. So 3x squared minus 13x minus 10. There's that. All right. So that's multiplying binomials. Now we're going to get into factoring. It's going to be a real quick overview. Do a few examples, but most of it is on the next set of notes. That's why it's separated A and B. When factoring, we want to start by looking at the number of terms we have. The number of terms will help us decide what method we should try to use. Always make sure once you have factored that you cannot factor more. So sometimes once you factored, those pieces you've created can still be factored. So if any piece can still be factored, you have to continue factoring. No matter what we choose, we always start with looking for a greatest common factor. Okay, that's why this is in the title. GCF stands for greatest common factor. That's the number one thing you look for because it works no matter what. So, the greatest common factor, start there. And the greatest common factor is looking at all the pieces. So if you have 2 pieces, you look at the 2. If you have 5 pieces, you look at all 5. What do they all have in common? What factors do they all have in common? Okay, so I'm going to start off with very basic stuff, right? Making a factor tree. So we're looking at a 4, which is 2 times 2, that's the factors, and x squared, which is x times x. So 2, 2, x, and x. Those are my 4 factors of 4x squared. Okay, and then I have negative 2x. That has a factor of 2, and negative 1, and an x. So those are my 3 factors, 2, negative 1, and x. Okay, now you look. Do they have anything in common? Okay, notice I'm breaking this down a lot. Most of the time when we go through this, I'm going to say, are there any greatest common factors? And you look at them and you pull out the greatest common factors. Okay, this is like one of the few times I'm actually going to go piece by piece. So notice we share a 2 and an x between these two terms. Okay, so we go back to our original problem now, 4x squared minus 2x. I'm going to take out a 2x from each term, but it should look very similar. So 2x goes in front, but the form that's left should look the same. So it should have two terms basically, no matter what. And you can see if I take out a 2x, I'm left with a 2x in the first one. And you can see 2x times 2x is 4x squared. What's left in the second one? A -1. A lot of people forget that. So that is my GCF factored out. Okay, so we always look for that first. And notice I cannot factor more. I would always check, can I factor more? A lot of times when you do a GCF, you can still factor more. If I had two terms, so this is any number of terms for GCF. That's why we always look for it first. If we have two terms, difference of squares. So a difference of squares looks like your first term is something squared minus your second term is something squared. Notice it says difference. That's an important distinction. That means it has to be minus. If there's a plus in between them, you can't do this. Okay. So if you have one thing squared and then another thing squared, your A term is the first thing, your B term is the second thing, you would have A plus B times A minus B. That's how it will factor. Okay. So when I look at this, 4x squared, so we have to think, is that two things multiplied? So that would be 2x times 2x, we just saw, right? So that is a perfect square. 9y squared, that is 3y times 3y. And it is a difference, minus. So that means my a is 2x, my b is 3y. So when I factor this, it would be 2x plus 3y times 2x minus 3y. And we have that binomial, two terms, binomial, broken down into its factor. Okay, then we have trinomial factoring. And these are the three things, by the way, you should have already learned in Math 2. Trinomial factoring, guess and check. This is when we have three terms. Okay, so if I have any number of terms, GCF first always. If it ends up having two terms, we might be able to do difference of squares. If it ends up having three terms, we might be able to do trinomial factoring. We're going to actually add more throughout this unit, more types of factoring. So it's not just this. All right, so we have 6x squared minus x minus 40. Where you start with trinomial factoring is looking at the breakdown of your first and last. And basically, you're trying to use these factors to create the middle term. Okay. This is called guess and check because that's what we do a lot of times for this. Once you start understanding patterns and things from doing these problems a lot, notice from doing these problems a lot, so please do a lot of these problems with me today and throughout the next couple of days, and we're going to have a lot of warm-ups about these problems because the only way to get better at this is practice. All right, so we have, breaking down this, we have 6x and 1x. And we also have 3x and 2x. Those are my two options. Those make 6. Okay. Usually, the easiest way to deal with it is the ones that are closest together. A lot of times with those, and then you move out. But I'm going to talk about how I like to do it. So now we're going to look at the 40. So we have a 40 times 1. We have 20 times 2. We have 10 times 4, and we have 8 times 5. All of those make 40. And it's negative, meaning one of these has to be negative. Because it's either negative 40 times positive 1 or 40 times negative 1. That's true for each one. Okay. So we know we're going to have one negative, one positive. That means when we combine, they're going to subtract from each other. And we want to make the middle term, which is negative 1x. So we're going to multiply these things together and make negative 1x. Okay, so we can kind of look at it. If I dealt with 40, even if I had a 6, All right, we know we're multiplying, so I'm going to multiply this one by 6. The closest we can get together is 36. Not going to work. If I had a 20 with the 6 times the 2, that makes 12. 20 and 12, when I subtract, it's going to make 8. Not going to work. Okay, 10 and 4. So if I use the 4, I could have, or the 6, I would have 24 and 10, which make 14. Not going to work. And this last one, if I had the 8 and the 5 with the 6 and the 1, 5 times 6 is 30, so 8 and 30 makes 22. Not going to work. So none of those are going to work with the 6 and 1. Okay. So we can look at the 3 and 2. The 3 and 2, we have to multiply both of them now. So usually, since you want it to be really close, we're going to multiply the smaller one by 3, the bigger one by 2. So that'd be 80 and 3. Nope. 40 and 6. Nope. Remember, we're trying to make -1. 20 and 12. Nope. That's close, though, right? 20 and 12 makes 8. That's getting a little closer. And this last one is 16 and 15. Oh, 16 and 15 can make 1. So notice my process here. That is actually what I do at the beginning. If it doesn't work when I check here, that's okay. It's called guess and check. This is how I'm coming up. I'm creating my initial guess using what I know. I know I'm going to be multiplying things, so I just kind of multiply in my head. Like, okay, I'm trying to make 1. Which one gets closest to 1? And that's what I try. So 3x and 2x is what I'm thinking. And I want to multiply the 3 times the 5. So that means the 5 has to go here, and the 8 has to go there. I think the bigger one I want to be negative, so I'm going to make that negative, that positive. Remember, one of them has to be negative, one of them has to be positive, because when we multiply -8 times 5, we have to get -40. Okay, so notice here, the first terms create the first term. 3x and 2x make 6x squared. The last terms create the last term. -8 and +5 make -40. So how we check, so if we did that correct, those will always work. We have to check the middle term. So how we check is we multiply the 2 inside terms, so -8 and 2x make -16x, and the 2 outside terms, 3x and 15 make +15x. And those have to add up to that middle term. -16x plus 15x is -1x. It checks. So that is how we know that's correct. Okay, so you multiply the 2 inside terms and the 2 outside terms, and that creates, and when you combine them, that should create your middle term. And so I have factored it. 3x minus 8, 2x plus 5. I am really good at factoring, so this comes really easy to me because I've been doing it a long time. You may not be really good at factoring. That's okay. If it didn't work, you try something else. Guess and check. Guess and check. Once you get good at it, it'll come easier. All right, so if we have 4 problems, I'm going to go through quickly now. I always start with GCF. So I look here, those two terms, they have a 4 in common. X squared minus 1, don't forget. Once you do the GCF, it should look the same. Inside the parentheses should look very similar to what it looked like before. So 2 terms in this case. All right, now I have to check. Oh, wait, I see 2 terms. Those are both perfect squares. So x and 1 make x plus 1, x minus 1. So I had 2 factoring steps. Always remember that. All right, next one. I have, oh, there's a 3, GCF, x squared minus 2x minus 15. Okay, so this is actually an easier trinomial factoring now because there's a 1 in front. So I know when I factor it, it has to be x and x. This is the only way to make x squared. 1x and 1x. So the only thing I have to worry about is the outside terms. So I have 15 and 1 and 5 and 3. And the only one that could possibly make a 2 is the 5 and 3. And it's negative, so I want the bigger one to be negative, the smaller one to be positive, right? Because I have to make a -15 and a -2x. And we could check. -5x plus 3x, -2x, done. Once again, I'm really good at this, been doing it a long time. It takes practice to get better. All right, so this is actually not too hard. This is still an easy one. A lot of people freak out from that number in front, but it's 3x and 1x. That's the only options. It's the only way you can multiply and make 3. So I'm going to have 3x and 1x. And remember, you don't have to write the 1. So 6, I have 6 and 1, or 3 and 2, and one of them has to be negative because that is negative, and I want to make 7. Okay, so remember we're multiplying, so I'd have to multiply 3 to one of these, so that's 18 and 1 or 6 and 3. Don't think that's going to be the one. I have 9 and 2 or 3 and 6, so 9 and 2. So I want the 3's to multiply, so I put it there, and I want the bigger thing to be positive. Okay, and then we check. Negative 2x plus 9x. Yep, that does indeed make 7x. Okay, and the last one, 2x squared minus x minus 15. So only 2x and x again, so that makes things a lot easier. It's an easy one. 15 and 1 and 5 and 3 are the only ways to make 15. Okay, I want them to be really close together, so I'm really thinking it's got to be this because negative 1x makes sense. And we can think if I multiply the 2 times the 3, it makes 6 and a 5, so that's definitely going to be what it is. It has to be negative once again, so one of them is negative, one is positive. I want the bigger one to be negative, and we check. Negative 5x plus 6x. Wait, that's wrong. Negative 5x plus 6x makes positive 1x. Okay, so I made a mistake. It was actually completely on accident, but I meant to put the negative on the big one. I forgot that I had to multiply, so that's negative 6x plus 5x. That makes negative 1x. See how guess and check works, even for someone who's really experienced. I checked, I noticed, oh, it's wrong. I made a mistake, so I think about how to alleviate that mistake. Okay, so that's the beginning. Remember, we're going to spend more time on factoring. We have A and B notes all dealing with factoring. So we will continue this again. Make sure you write your 3-sentence summary for this one.